This is a great example. This is from the expected value section 11.3, and it's the wheel that Dave is spinning, and he has a possibility of going bankrupt, losing a turn, or winning all these different prizes. It looks like this is slanted really nicely in his favor, but to really calculate how much he could expect to win over the long run, we would need to work out the expected value. So part A is a little bit easier because when he lands on this bankrupt, let me highlight these. If he lands on bankrupt or lose a turn, there's no gain and no loss. So to start with for part A, we would simply need to add up all the different numbers around the wheel and divide by 12. Let me show you why. What we're really doing is saying the probability of each equally likely outcome is 1 in 12. Could land on any of those 12 spots just as likely as any other. So it's 1 in 12 that it would land on 900. 1 in 12 that it lands on 600. I just went around the clock clockwise. 1 in 12 that it lands on 0 for lose a turn, 100, 500, 700, etc., all the way around. So it's 1 in 12 times each of these. I could simplify this process by saying 1 in 12 times the sum of all of them. Again, because they're equally likely, this works. So that calculates down to the 5,500 divided by 12, which is $458.33. Well, we get a little bit different scenario if we say that Dave already has some money. Now we actually have something to risk. Now, if we're saying that he has $1,800, then this bankrupt is no longer going to be a 0. The bankrupt is now going to be minus all of that money he's earned. Use the word earn kind of lightly here, right? So now when I calculate this 5,500 minus 1,800 and divide by 12, we see that his expectation is still positive, but it's dropped to $308. 0.3 repeating, so I'm going to round it to the nearest cent by saying $308.33. So I hope that this video helps you understand this problem a little bit better, but notice that this going bankrupt means that he loses all of the money he has already saved up.